Sorry about that. Maximum file size was reached. So I'll explain the Monday assignment, week 2 Monday. We see that beer sells for $5 per barrel and ale sells for $2 per barrel. So we get Z equals 5x1 plus 2x2. Now let's look at the corn. So beer requires 5 pounds of corn, ale requires 2 pounds of corn, and there are 60 pounds of corn available. So, sorry, I'm shaking my leg. 5 plus 2 less than or equal to 60. Alright, that's our first constraint. Then hops. Well, beer requires 2 pounds of hops and 1 pound of hops for the ale. So 2x1 plus x2 less than or equal to 25. Because, yeah, beer, 2 pounds hops, ale, 1 pound hops. How much hops available? 25. Alright. So we're going to basically just set these inequalities, isolate for the x2s again, set them equal to each other, find where these inequalities intersect. So it seems like they intersect at x1 equals 10 and x2 equals 5. You plug that in, so 5 times 10 is 50, 2 times 5 is 10, 50 plus 10 is 60, so we get z equals 60 at that point. But that is not how you solve an LP graphically. That is how you solve an LP algebraically. So we're going to take a look at this graph. Woo! And basically this graph, there was a lot of space here, and I guess I just miscalibrated how much space I really had, because this is just a tiny little section of it, but I'll call it space efficient. So there's 3 points of interest really when graphing these two inequalities. So you have when the x is 0, you have when the y is 0, or x1, x2 slash y axis, x1 slash x axis, you know what I mean? So yeah, horizontal x or x1, vertical x2 or y. That's basically your axes. So we have 2 lines. They're kind of hard to see, but I swear they exist. The steeper one is the corn line, and the less steep one is the hops line, because as you can see, the corn has a slope of negative 2.5, whilst the hops has a slope of negative 2, so the corn line has to be steeper. So we're going to check where the x value is 0, the y value is 0, and the intersection. Well, the y value, let's just plug in 0 for x. Okay, let's just look at this and just plug in zeros. So, they're gone. 2x2 less than or equal to 60, we can divide that. We can say x2 is less than or equal to 30, x2 is less than or equal to 25. Out of those two, the second one is more strict, so we have to go with that one. So essentially we're looking at 0, 25. And we plug that in. 0 plus 2 times 25. 2 times 25 is 50. Well, so at that point we get z equals 50. Now let's look at the intersection, which you could try eyeballing it if I actually wrote it a bit bigger and maybe to scale and something like that. I'm a mathematician, not an artist. I'm barely a mathematician. I'm just a dude making a video. Yep. So we're plugging in the 10, 5. We get 50 plus 2 times 5, so we get 50 plus 10, so we get a z equals 60. And now let's plug in the that bottom point as well. So we can try plugging them in here. Let's try making the x2s 0, and let's see what happens. So if the first x2 is 0, then we have x1 less than or equal to 12. We can plug 12 into this, we get 60. Plug 12 into that, we get 24, so it's feasible. And if we set this one equal to 0, we get x1 is less than 12.5. Plug 12.5 into here, and it's bigger than 60, so that's not feasible. So we're only really looking at the x1 equal to 12. So So we're going to plug in 12 comma 0. So 12 times 5 is 60 again. So we got z equals 60 here on the intersection, and a z equals 60 down here at the bottom of the corn line. So technically both those points are on the corn line, so I guess I could just say, let me just erase something. I don't want to accidentally, good night. Alright, brought you back to life. Carrying that forever is just annoying. Alright, so it's optimized on the corn line because we have a point on the corn line here and a point on the corn line here that have the same optimal values of z. So we know the whole corn line is just going to be a good time to be. Well, actually, any spot in between the intersection and down here, really. Because past that, it's not really, it's not feasible. So yeah, only between the intersection and the x-axis for on the corn line, that's where the optimized values are going to be. And they're going to be at a value of z equals 60. So I hope that you learned from this video. And this stuff on the left is just simplex evilness. And don't forget the non-negativity. You always got to stay positive, and we'll get through this stuff together. Yeah, just stay mathin', stay rocking on, and Caden out.